So today we are not going to be working on the truck. I put all this stuff together, and my dad actually has a friend that puts it together, so I'm going to try it one more time. But that's a really tight fit. I haven't even looked over any of those YouTube videos, but because I got caught up in this other project with the autism spectrum disorder, and we made the data frame that we wanted of our 4 classes, but we didn't make the matrix. We're going to see before we look up these genes how well these gene loci, the top 20 of each class, are going to predict out of all 4 classes what type of autism they have. So they call that machine learning. And that's what we're going to do. I'm going to share my screen. The entire screen. We'll just go into it now. Oh, let me take you also after I'm done doing this. I'll show you where the RPubs file is. And it has links to all the data that you want. Before we go, I don't get ready for work till 11:30. Desktop. This one. Part 1. We actually did part 2, but we didn't save it as part 2, so it's all part 1. So if you go in the RPubs, it'll be the last 2 things we did to it. That was my dog, I swear. This little one. I just gave him some eggs that I put everything bagel seasoning on, and I hated it. It tasted really gross, so I gave it to them. They want more. They love it. Their rest and digest is in effect. Okay. So this is our file. We came up with all the stuff. We'll just run all the chunks right now. We'll just keep it as it is because I'll just keep saving it. But at the end, I'm going to add that it's going to be part 3. So now I'm going to take you to my site where we can do, it's not really my site. It's just where I have these at. Okay, so we're in this one right here. Because these ones are on the lymphomas, and I talked to you about those briefly. That was one separate project because I'm doing a larger project with Epstein-Barr virus. Here's the analyzing genes. You go into it. This is all the work we did. This is how it looks when it's published, the way that we had it. Everything that we did in order with all the files. Now, the links. Oh, shit. It's because I'm in... They said that they wouldn't let me in yesterday because someone was trying to interfere with me logging in. I think that's just the YouTube Go Live thing. It's not impossible. It's an AI hacker. I'm too small to have someone hack this. So this should be opening in a new window. Or, oh wait, do I have a new window? No. So let's open it in a new tab. Here we go. That is to the expression profile. And to get from the start, if you want all that data, you just go here. That's the, these are the raw tar files though. That's the one, custom. Those are where you get all those 116 unzipped MEV files. And then you go into each one and unzip them individually. And then you go into each one of those folders in a separate folder because you have to make that full folder. And then you take each file from there and put it in another file where it's only the files and no folders. And then you create a path and you call it from that. That's what we did. And then it has more information about the samples. This is the series data. I believe it was the text one. Yeah, series matrix files. That's where we got all that information with all the commented tags and exclamation point tags that we got information about the file, and we attached the sample name to the type of sample, like control for healthy or, you know, the mild, the language, silent types. All right, that's where we got that. Janice, like rpubs.com, Janice Corona, and then you just go to this one. It's like the third back. We'll just keep adding to it there. Let me make sure that this is showing. Okay, it is. I'm sharing the entire window. Data science and coffee. And then, so we ran all the chunks, and our environment has all these objects there. Keep in mind it is taking up 1.94 in memory. So we could remove all these extra GSM files. We'll just go ahead and look at, let's set our working directory first. It's already there because we opened the file, but it's good to just know it. We're in the console right now. So now we're just going to ls the files, ls parentheses, and those are the files that we have. Let's make this. I want to remove all these GSM sample objects that we don't need. So I'm going to go ahead and copy and paste them. Oh, shoot. To remove them. Because it's going to get really messy if we don't. And then we'll have to figure out where we were. Okay, so Control C in my PC. And then we're just going to RM remove. We're going to copy and paste, but we do have to delete all of this stuff. The neighbor's doing some shit. He's a crackhead. I have to put commas in to remove all this. Oh, and I reset my password to my web dash cam. Actually, it wasn't enough. I was able to download the app. Okay, looks like it's good. We have all GSM beginning them, so we don't use these objects anymore. And we'll go ahead and remove them. So now our environment is less cluttered, which is good because we're going to be making more objects. We can go ahead and remove file 1 and 2 if we want, but we're not going to use those. So, I mean, we might want to be like, oh, well, hey, what is that again? Okay, we can always just run all the chunks because it doesn't take that long. Once you remove it, if you already removed it, just like I said earlier, it's a script and it goes off everything. So, because you correct an error message here, you have to rerun everything because those objects aren't going to be in there. If you have to just know what you're doing. All right, we're just going out the same script. We did not save this as part 2 or 3. So now I'm going to just go ahead and separate it though, just to know where we're at. I like to just put a bunch of equal signs and then some asterisks and then label it part 2, the machine learning. So we have to make a matrix of this data, and our data is this. Big data is what we got the top genes from, but we want to see before we go and find all of these genes if they can predict the class of sample. All the samples are on the top, but they're covered with other rows. Right here, the column names. We already know what class they are by this class object. And then, so we have 116 samples. We have the gene, if we go to the very end of all of our columns, we have the, we haven't merged it yet. Wait, didn't we? We already did that. Okay. Yeah, so we got to go to the end. We're not at the end yet, are we? Oh, I guess so. The fold change. Okay. The user ID. Okay, so we didn't. Well, no, we should have the gene break accession number on here. That's weird. Okay. So let's go back and see what happened because we took the top 20 from that data. It is there. We merged it, and so when we merged it with the platform yesterday, it had the gene bank accession number in it. I don't know. I guess not. All right. Let's see what happened. So we'll go up to the top and the short platform. Short platform is actually where we got it from. That's where we saw there are 4,172 rows. The gene bank accession number. And then we have the UID. Merge top language FC with short platform by you. Okay. So Savant 20 mile. They all have 129 variables, and then our top ones only have 126. I think I took it from the wrong data. That's why. So we did merge it. We can go ahead and correct that now. Because the top language, whenever we made that one, We didn't take it from the right one. Well, just okay. So language 20 GB. Okay, 20 rows. Oh, because it's not the top ones. It's the language 20 GB. That's the ones we saved. You can also read in these files that we wrote. So we're just reading in the wrong. We haven't even read it in the file. We're just making sure we're reading in the right one. So it's this one, the ones and then 20 for gene bank accession. Okay. So we'll go ahead and look at that one. And they have the user ID that we merged with the platform to get the gene bank accession number. We're going to be keeping the gene bank accession number because we're going to pretend that's our gene, but it's actually got a location on the chromosome where there are multiple genes. When they first discovered what these genes were, they were getting locations on the chromosome to fit it. And then they realized when they started getting same, well, they already knew what they were looking for, the same locations. Oh, that's a gene. Oh, look, it's in the messenger RNA. So, what's so these gene bank accession numbers, we're going to be seeing if we can use those. These blank ones we can't use because they don't have anything there. So it's basically something that we can't use because it doesn't have a gene bank accession. So all those blank ones we can't use. So you're not really going to get top 20. You're going to get some genes. Okay, Dallas, we love you. Dallas, we love you. Okay, that's it. Thanks. And we have to make a matrix. We're going to put those samples as the observations, which will be the rows. Right now they are across the columns because we're in the genes and we have the genes. So we will just use each little table. Let's get the column names of this savant 20 GB. Okay, now we only need the samples in this order because we're gonna merge. We're gonna put the class on it too, and then we also need the gene bank accession number up until this one, and then the gene bank accession number, which is GBACC. We're gonna just take 125, 26, 27, 28, 128, and then it's gonna be 4. These are the columns through 119. So we're using columns 4 to 119 for samples plus the loci gene bank accession ID as GB ACC column 6, 7, 8, 5, 6, 7, 8, 128. 8. So we'll just go savant TF 20. And we're just gonna make we're just gonna extract those columns from it. From the savant 20 GB, all the rows, because those are the genes. And then we're just gonna make a vector 1:119 and then 128. We'll look at what it looks like. Oh, yeah, actually we needed 4 through 119. So let's go ahead and look at that. I'm gonna run that again. Oh, good. 117 columns. And if we scroll to the very end of the columns, it's listing them at the bottom of this table. We have the gene bank accession ID. What we can do is just do complete dot cases because these are going to be our columns and we can't have null values for columns. So we're going to savant 20 df complete cases, and we'll do savant df 20 complete dot cases savant 20 df 20, and then we'll go savant. We'll just do the dimensions of it. We can actually see that in our environment, but we'll just look at it because it's not going to be showing our environment in the display. So now it still has 20. Oh, 20. Well, it shouldn't. It should not have 20. Okay. Complete that cases. Okay. 20. Okay, we'll just do. ASD. I think we can do not is the wait, okay, hold on. So won't you not equal? No. We'll see if that works. Okay, no, it doesn't. It's a character. Okay, so which savant df20 by DAC? No. Complete the cases. I'll just do that. Let's see if that works. That's not okay. Well, let's just see what we're working with. Savant df20 df5 db. Do you not run this one? df20. Oh, okay, I did it the wrong order. That's why. Okay. Okay, so I'm going to put that this is a factor. You basically just do as dot factor savant, and it stores it like this. See, and then savant df20. Let's see if it fixes this problem. Okay, so there's nothing there. Now it's not in character strings. Okay. Which savant df25 GBACC is not equal to null. All right. Okay. So it just doesn't have an ID. It's not showing in the I'll run into problems like this. It's not showing in the actual viewer that there is an NA or a null. It's just empty. It's blank. So, I mean, it doesn't tell us anything because we're not able to use it. So, okay. See, for this one, I guess we could just manually remove them as well. So it's the second column, second row. Okay, so okay, which is dot and let's see if that has anything. Empty is dot null. Empty. Okay. Let's just order them then, and then just remove them. Let's see if that works. Alrighty. Yeah, okay. Mm. 14. So we have 14 of them. So we'll go ahead and remove the. We're only going to take the 14 rows because the other ones we can't do anything with. But we'll go ahead and look at that. Hold on, let me let my dog out real quick. All right. Get out of the way. Okay, love you, babies. Get out of the way. Stop. Okay. So, let's go ahead and remove that one. Let's make a whole bunch of these little chunks. With space in between. Because we will be running a bunch more code. It just makes it easier. Okay, so we're just gonna take the first 14 rows. We'll do that. So we're gonna do SV. Filter 1 to 14. We'll look at what we have. What? Hold on. It should have been the order. So this is the ordering of that. SV is 20 observations of 117 columns. We just took the first 14 rows and we wanted all columns. And here we have a different display. It is not showing that. It is only showing 14 columns. So let's put it like this in a vector form. Oh, and that's a period. That's why. Yeah. Okay. So now it has 117 columns. And then these are all the samples, 116 samples in order. Because we put them in order. Whoa. Okay. And then bunch of zeros in these for some of these samples. And these are the accession numbers right on the last column that we can use whenever we go to a site that offers the chromosome viewer. I haven't been able to access Ensemble. They might have blocked my IP address. I don't know why. I have no idea why. It's a public domain, so I wasn't even scraping the website. Or they just are down because I guess they had the federal shutdowns and stuff. So they could have just been like totally boycotted. They could have been actually destroyed and then just left there because of the current leaders. So what we would do with this is now we got to make a matrix. These are the genes. We're going to have these as columns. These are the samples. These are going to be observations. We're going to do a classifier because we have a class here. What we need to also do is get the rest of we need to make the healthy ones as well. We have to take these gene bank accession IDs from the healthy samples as well and see if it can make okay, so we want 4-class model, but we could do a 2-class between solvent and normal. So let's go ahead and make because right now we're just predicting the class of solvent. So we're gonna have to use all these samples in the healthy, extract all the healthy. Sample that one. We didn't make a separate database form. But we have this short platform that has the UID in it. Gene bank accession number that we can merge with the healthy data samples. All right, let's just go ahead and get all the gene bank accession numbers. Let's we're gonna just put a different column because to each one of these data frames we're gonna add where this is. So let's go ahead and ECC 14. We're adding a column. It's gonna be class, and it's going to say savant ASD. And then we'll see that because we're going to do this to each of these tables. So it has that. And then when we combine them, all of the samples will be the same, but it'll have the class with it. So let's go ahead and once we do that, then we'll get the healthy ones with these genes and see. Okay. Or we can exclude some and then do the machine learning. Now we're going to we have the savant top team genes due to limitations of the ACC. Now we will get the language and mild top 20 usable look, and then merge with the healthy samples of with the genes in the larger data to get the healthy. Okay. So actually, it's early. I just had coffee. So these samples are the healthy or the we're just gonna avoid that last one. Okay, hold on. So we can just delete this because we already made the table. We don't need that. It's early. Okay. So the healthy samples, it's already listed here under our class one for which ones are the controls. So now we'll just we can actually make the matrix right now, and we'll just extract only the samples of those 117 that are once. Okay, let's just make the matrix. Okay, SVMX for savant matrix data dot frame. Let's lower this. There's so many different names for variables, and RStudio likes to mess with me. It puts the console. So sometimes if I have the console open, I'll like lower it and it'll jump like 10 to 20 lines somewhere else. So I'm just like, oh, okay. So we're just making a data frame. We have to transpose it, which is basically, it's like this, columns at the top, which are the samples, observations are the genes. We're going to flip it. And now the genes that we picked are the top and the samples are the observations. But it's going to be matrix, so it, we don't want to include the gene bank accession number as that, but we do already have it there. We're going to add that as the header, which will be the gene bank accession ID. Okay, so we transpose over the T, parentheses, savant, G, B, 14. And then we only want to take 1 through 116 because that 117th column is we're taking the columns. It's always row, comma, columns. On that 117th column is the gene bank accession ID. So that is going to be our header for this matrix. Okay. So then we're going to go SVMX, like column names of this new matrix are going to be the savants GB ACC 14 by GB ACC. Then we're going to add the class to it because it will have all samples right here by class as dot factor class. And then we can go ahead and look at what we made. Subscript out of bounds. So transpose. Oh yeah. So actually this goes inside the T parentheses. And here we have our genes at the top, our samples right here. We're gonna go, there's not that many columns now, which is great. That's the kind of matrix we want. We have our controls. We're gonna isolate by, we're gonna filter by control because by the class because we only want the controls and then we want the savant. So we can just make sure that we have the same, the row numbers. Should match up on the first one with the savant. And if we go to the very end, these ones will be these ones at the very end are the savant. Make sure. Yeah. These are the first are the controls, which are the healthy, which are the earlier samples. Okay, good. This looks good to me. So now we're gonna filter by that, and we're gonna see how it does in a 2-class model with these genes for healthy versus savant. Filter by to only get the healthy controls and the savant ASD, because we're going to use it to predict a 2-class model of savant ASD or normal healthy. Okay. So okay, so we'll do healthy savant MX. We are going to use this one, SVMX, and then SVMX by class, identically equal to control or SVMX by class identically equal to savant. Let's make sure that's all right. Let's go ahead and open back up our. Oh, now it did no money, huh? Class and make sure we spelled it the same way. Savant. Okay. Lowercase. Okay. All lowercase. Undefined column. So, oh yeah, that's right. So we need to put this in. Actually, we can just put a column here. Now we're gonna go look at this. It's just easier if we just look at it right here, but we will print it out also. Controls and savant. Okay, so we have 59 samples, and we can tell how many of each we have. This is gonna be our matrix to predict. We're gonna do a table of healthy savant MX by class. Run that line. Okay, yeah, so because it is a class feature and it knows that these are the original attachments to it and there aren't any there, it still lists the language in mild, so it might act like a 4-class model. We could just try saving it again as a factor and see, as a character and then as a factor. Healthy savant MX by class as dot character. Healthy savant MX by class. And then let's see if that works. Yeah, so it's 2 of them. But for our matrix to work as a classifier, these have to be factors. So we have to turn it back into a factor. Let's see if it works. Yeah, good. Awesome. So now we're going to import our library. It's called Random Forest. And if you don't have it, you can install it with this. Not the hashtag, but it would be basically just install.packages random forest. Yeah. And then it would take the updated one. There's other ways to install it, but I just stick to that one because you can always Google it. AI is really good. So I'm going to go ahead and remove that one. I'll just leave it because somebody actually watch this and need it. We're going to use that library. I'm going to show you because this is the best classifier. You can use other things for classifying like Bayesian models, principal component analysis, clustering. But those are more, the last two, clustering, PCA model, those are more for information you don't know what the class is, and it just clusters it on its own and says this is the similarities of this group, the similarities of this group. There might even be a third group within that group, or maybe 20 groups in that group that it'll find. PCA, it does it by the most variation. So it takes vectors to split up all the data where it's so far from that line, which meaning it's so far from an average of that direction. It takes all these components in every different direction in 3D space of all the values, and it tries to find the most variation. So you'll have a principal component 1, 2. So far from here, this explains a lot of variation. It'll take those samples. But the thing is, it's the samples. So it's not really the genes, so to speak. It is basically getting you the variation, the error, and then you're supposed to get back the actual genes that are in that component, because those 3D spaces are using those genes as components, as like, let's say gene 1, gene 2, just a 2D dimensional space. They'll use all of that all over the place and then put it together. Yeah, it's confusing, but that's what it is. It uses what's called SVA, stochastic variant, or SVG gradient, stochastic gradient variation, which is basically using irrational numbers. Like it's using square root of negative I in a rational number times square root of a negative I, a rational number, is negative I, which is -1, I think. I don't know. It's been a long time since I did math. So if you do two irrationals together, it creates a number in space that is real. So we have our random forest. Now we're going to use that. It's jumping. Healthy Savant MX. It's right here. We'll just remove all these other ones we don't need so we can know what we're working with. And it's right here. We didn't really do a page table of it on our viewer, so let's go ahead and do that. Oh, yeah, that's right. I put by class. Okay. No, we're good. So at least when it's in the viewer, even though we know it, which it is, we might not know it at a later date or somebody else. And it's like, that's not what it is. And then we have our features. Let's make sure they are factors, because we made it a factor as the last thing. We just made it characters. I'm just going to put a note here. Remove the two classes. Sorry. That's 4 classes. All right, and then let's make sure that runs in because it's a long comment. Okay. Install that. Okay, so we're going to be working with this matrix. What we're going to do is we're going to make some randomization. We have 59 samples. So let's go ahead and create a spacer to hold the way that it separates the two. We're making a 2-class model. So we're going to use sample function. And we're going to do 1 through 59 for our samples. 30 plus 29 is 59. We're going to take 80% as our training set times 59. And it's going to make a random vector of samples. But we have to set the seed because we want this to reproduce the same results the whole time it runs. Every time it runs the same thing, because it will produce different results guaranteed if you do not set that. That's from the random generator inside the computer system, RStudio, or the computer system. Because it's manipulating whatever is the process is in the back behind all that. And then we're going to make a training set. That's the 80%. We're going to train our model on classifying it with this. And we're using the matrix healthy Savant MX in train is basically just those rows by indices. I'll show you. And then the testing set is going to be the opposite of those, which is pretty easy because you just put a negative sign. It's not what's in train. Okay, so in train, just randomize a whole vector of those samples. And yeah, you can do that because it works with that function. So let's see how many are in each class, because you do want to balance as best you can, or at least have all the samples in each set. There's 20% we're going to have a holdout validation test to test our model on. Training by class. Okay. So in train is a value. So it's basically those 1 through 47. Oh, what the heck? Okay, so it took 47 of them. Okay, so it's 47, and then it left 10 out because that's the 20%. And now let's see, and it has almost a fair balance in the training class. So let's see how many are in the, because it will be 20% of the 59, which is about 10. They did, or so, or they said 12. Okay. So yeah, there's enough in each class. That's good. It's as balanced as it can be at 80-20 split. Now we're going to predict with our model. So we're just going to make a random forest healthy savant. I'll just put, yeah, health. Yeah, I'll just do that because that's what we're going to do. Okay, random forest is our function from that package. And then we're going to use the training set. And I found that it's easier just to do this. Oh, you don't put a comma. You just do 1 through, because of the number of columns that are in it. We're not using one of them. So there's 15 variables. The last one is the class. We're not using that one. So we're going to use 1 through 14 for that. That's what it's going to train on, and it's going to predict on training by class. Now we're going to do an M-try, which is how many samplings they do, because it's a classifier. 1 out of bag, they hold 1 out, they predict, they're getting whatever is in the most group for that sample. It's doing a whole bunch of these. So I read, if you go to the help menu and you look up this, you can enter it and you can read some stuff about it. You can also go online and search through various things. But the M-try, there are also other methods to use to get the M-try, which is how many to use to leave 1 out of bag and then resample for these genes, which are the classifier. So we have 14 genes, and they say it's good to just split it into thirds. And whatever 14 divided by 3 is, it's close to 5. It's also close to 4. So let's try 4. And then the trees are how many trees they try to grow this into by different divisions that it does, by different rules that it comes with. I usually just use 5,000 to start. I haven't tuned any of these yet. I'm just a basic model. And we have to put confusion equals true. And then we can also put importance equals true too. And then we can look at the confusion matrix. So our class error is not that bad. So this is how much error it had. For the healthy classes, it only had 4% error, so at 96% accuracy. It predicted 23 healthy as healthy, but 1 healthy it predicted as savant. Now, out of the savant, it predicted 20 correct out of 23 samples. So there were 24 control healthy samples, 23 out of 24 were healthy. There were 23 savant samples, 20 out of 23 were predicted savant. So 13%, a little bit more error on the savant. So that's a pretty good predictor on a 2-class model. I'm just gonna good predictor set of genes for savant versus healthy samples on a 2-class model, but it does correct. So we need to see how it does on prediction. And we can also look at the importance of each gene too afterwards, because I found that sometimes it doesn't let me run it. So this is going to be our predicted healthy savant. And we just use the predict function after running random forest. Predict, we're going to predict that random forest model, which is an object right here that has all these listed items. And our confusion matrix is there. It has an importance for each gene there matrix. So it's like it's an array, basically. Array can have values. It can have other arrays. It can have matrices in it. It's just a big toolbox of different things. And we're going to use we're going to test this random forest object on the testing set, the holdout testing set. All we do is that. And now we want to see the results. So I'm going to make a data frame of predicted equals predicted HS actual equals testing by class. And then we want to show this. So let's see. Oh, great. So it shows us it. Okay, so these are the actual values. Control. Okay, so 2 controls were predicted savant so far. All the savants. 1 savant was predicted control. So prediction, not so great on those ones. Yeah, so it looks like we had 12. Okay, so on the predicted model, there were 12 samples, and let's count the savants. So there were 2 savants here, 3, 4, 5, 6, 7. We have it actually up there too. 7 savants. 7 savants total with, okay, 1, 2, 3, 4 predicted correct. 5 with 5 out of 7 predicted correctly predicted savants. The other 2 out of 7 incorrectly predicted healthy control. There were 5 healthy control samples, which we go to all of this. Okay, 2 were predicted savant. 2. Okay, so 1, 2, 3, 4, 5. Oh, there were 6 of them. Huh? Wait, 1, 2, 3, 4, 5. Okay, so yeah, there were 5 control samples. 1, 2. Okay, so 3 out of 5 were predicted correctly. 3 out of 5 correctly predicted control, and 2 out of 5 incorrectly predicted control. Healthy. That's okay, but the model accuracy, because it incorrectly, the accuracy it over predicted on, this means it overcompensated or over predicted. It there is an actual term for that. The training set. So it overly fit. It overly fit the training set that did not generalize to the testing set very well. On the validation test set. Okay, so 5, 6, 7, 8 out of 12. 8 out of 12 correctly predicted. That is 66% accuracy. Right? Okay, let's see. Yeah, let's say 67% accuracy, with Savant having a 5 divided by 7. 71% accuracy. And Control having a 3 out of 5, 60%, having a 60% accuracy. All right, so we would do this for the other ones. I'm actually making chicken fettuccine right now, so we'll get to that later. Let's go ahead and knit this. Because we're going to have to test the language and the mild as well, and then do the 3 class model. It will be on the same page. I didn't change the actual name there, so it will be the same one. We still need to see how well the language GB, ACC, IDs, and mild ones compare to healthy in predicting their ASD group compared to healthy. Then we will see how well all these genes together or separately or both predict a 4-class model of healthy, language, mild, or savants. Usually beyond 2-class model, there's no improvement in accuracy for a random forest, just because there's too much to separate and you have to tune it. And you can tune it with different ways of doing stuff. But I'm not going to do this right now because I will have to get ready for work pretty soon, and I am making chicken fettuccine. Oh, wait, awesome. So stop by next time and visit this site, rclubs.com. Janice, what is it? I think it's Corona. Yeah, Corona. Yeah, it'll be this third one. If you want to download it, or I can share it, or I can copy the link. I'll just copy it. And I'll put it on the live stream. Okay, yeah, I'll put it on the live stream. Very cool. So I'll do that. I'm going to stop sharing. And I will add that to this. Okay, great. So I will go ahead and do that. I'll add it in the chat. And then I'm going to go ahead and end the stream.